Today we're going to be talking about validity and the different types of validity. We're going to really focus on internal validity today. So before we get started, let me just go over the types of validity. We'll go into more detail about the other three types, but we're really going to focus on internal validity today. So external validity, we've talked about this a little bit in our article critiques, and that's just how well we can generalize our study results to other people, other cultures, other times. Will this, generalize to later times in the future? If we're reading an article from 20 years ago, does this generalize to now? So external validity gets at how well the results generalize to other times, places, or people. Construct validity gets at how well the measures we have get at the construct we're interested in. So if we have a measure of depression, how well does that measure of depression really get at the construct of depression? Statistical conclusion validity is just, are the stats properly used? Are they interpreted well, etc. So we'll get into more of that the second half of the class. And then the final one is internal validity, and that's what we're really going to focus on today. So internal validity is, can we rely on our independent variable to talk about the results? Or another way to say it is the independent variable responsible for our results. Can we rule out everything else and rule out all alternative explanations? And in an experiment, we think that that's the case, that we can rule out all alternatives, but it's not always the case if we have some confounds to internal validity. So let me go over some of the confounds of internal validity. And I have what are called the Big 10 confounds. In different textbooks, you'll find different numbers of confounds, but I like, these are kind of the 10 that I find that are most common. There'll be some overlap between these. Sometimes you'll see something that you can call the same problem in the research. You can call it by two different confounds. So the first one we're talking about is history. And with history, that things outside of the experiment can affect the results. So for example, if you have a new researcher coming in, a research assistant coming in and does something slightly different, if something outside of the experimental condition is what's screwing it up, that maybe somebody forgot to do a certain set of instructions, or forgot to place the mouse in a certain spot, or something along those lines. Something outside of the experiment happens that might affect the outcome. The second one is maturation, and this is something that occurs within the person, that changes within the study. So history is something that's occurring outside of the person, outside of the experiment. Maturation is something that's occurring within the person. So I think of the MMPI test, it's a personality test. The MMPI-2 had 465 items. There's a revised version that has fewer items. But over 465 items, people get fatigued and may not be reading the items carefully. And in the MMPI, they actually repeat items, or they might be slightly worded differently. So there's first half and second half, and sometimes the item on the second half is coded differently than the first half. And that's something that related to fatigue, or maybe the person's not reading things properly. So throughout the study, the person could change, and that can affect the outcome. So we call that maturation. The third one is called instrumentation, and that's something that changes with the calibration of our measurement devices. So anytime we've got a measurement device that we have to adjust, like a scale, the scale, we think of it as being perfect, but there's actually some variability in how reliable the measure is. And we have to calibrate it. We have to get calibration weights to measure it. Or we play a startle noise for some experiments, and that noise could get louder or softer, so we have to calibrate the volume of what the person hears. So a lot of anything with instrumentation that might adjust. If we're doing any sort of fMRI or EEG study, we need to calibrate our instruments. Otherwise, it will be different results for different people or different time points. This next one is testing or practice effect, and we saw this in that first article with the fear of flying. And I put the graph up here to show that basically people got on an airplane, took a test of their anxiety, and then realized the plane wasn't going to take off. So the first time they did the study, they were quite anxious and quite scared that the plane was going to take off. The second time, they might have had that practice, or that practice effect came into play, and they're no longer afraid of the plane taking off. So they have less anxiety the second time. So it looks like the treatments worked in this graph here, but it might just be because of the practice effect. They've figured something out as they've taken the test twice. This one is somewhat of a complicated one to describe. It's statistical regression, or regression towards the mean. And you may have heard this before of like a sophomore jinx or a rookie jinx in sports. And this was this table here is batting averages for the person who won Rookie of the Year, and then the second year they usually tend to go down. So this was from 1970 to 1994. This was a study that was done quite a few years ago, but just what was called the sophomore jinx. And regression to the mean is basically this idea of that if you've done really, really well or really, really poorly, you don't have much room to go up or down. So in this figure here, if you've towards the bottom, you can't get any worse. You can't, if it's a depression score, you can't get any more depressed. You're as low as it goes. So the only place for you to go is to go up. And that people who are really, really depressed, really high, the only place that they can go down is to go down. So there's not much room to go higher, or if you're already high, or lower if you're already low. So that's this concept known as statistical regression, that the place that you're most likely to go is towards the middle. So if you've won Rookie of the Year, you were really, really, really good. The second year, you could be really, really good, but it's more likely that you're just going to be pretty good or slightly good. So that is going to show this sort of decline in your performance. So that's what statistical regression to the mean is. If you have a really high score, you can't get any higher, you go back to the middle. The next one deals with random selection and random assignment, so we call it selection or assignment. And it's anything how we assign people to the groups, if there's any bias in that, if we let people choose. The one I give is there used to be therapy type of studies where people were looking at psychotherapy versus medication, and they were just finding people who have done one or the other. So there was no random assignment. People had chosen to take pharmacological treatment or to go through therapy. And when this happened, there's bias because people choose one or the other based on their preferences. So there could be bias with this. So this is assignment to one group or another that's not random. And same thing if you're selecting certain people to be part of your study, that can also bias the results and change the outcome. This one has such a severe name, mortality. Probably better to be called attrition. But this is anything where people drop out of the study. And this also happened in that fear of flying article. We had people who dropped out, and because it was such a fear-invoking type of study, they dropped out. And the people who remained likely did better because they were better suited for that type of intervention. Extreme fears. So any type of or more attrition from the study, I'm going to try to call it attrition, not mortality. People dropping out of the study might bias the results. The people who left might not have been well suited for that treatment, and the people who stayed are the best fitting for that type of treatment. So we have to also look at the people who dropped out of the study. The eighth confound to internal validity is sequencing. So anything that changes the order of events. If you go through one type of treatment and then you're given another, maybe the first one primes you to do better in the second. So the order of the procedures can change things. We'll talk about it in a coming lecture about the order of self-report questions. So if you ask people how their relationships are, and then you ask about their general life satisfaction, the next question, their general life satisfaction is really related to their relationship status. Where if we ask those questions far apart from each other, they're not correlated as much. So the order can prime you for the next question or the next topic that's coming up in the research. All right, this one has quite a few names. I'm going to call it generally participant effects. But I feel like I need to give you those other names for it because in licensing exams, they can often pop up with different names. So it's participant effects, and that's anything that the participant is doing based on what they think they should be doing. It's also called demand characteristics. So they're thinking about what the study is demanding and acting differently. And this really came about from a study at the Hawthorne Works Electric Company. And in this study, they had scientists come and observe people there. And no matter what intervention they did, people performed better, did more work than they previously had done. And they called this the Hawthorne effect. So that's another name for it. Because participants know they're in a study, they act differently. And that's all of what this is composed of, participant effects. Being part of a study, they're trying to figure out what the demand characteristics of the study are, and they're acting differently to try to act like they think they should in whatever they think the study is about. And then this one is on the other side of things, this is the experimenter effects. This is if the experimenter acts differently or biases the study. So if the experimenter knows what the hypotheses are, they might act differently and prime the person. So I like the story of Clever Hans as this horse that was thought to know how to add and subtract. And so if the owner of the horse would say, what's 2 plus 2? The horse would pound its hoof 4 times. And what was really happening, and I've read different accounts of this. One is that the owner was unconsciously cueing the horse. That when the horse was getting close to 4, the owner was nodding, and the horse could tell that I'm close and would just stop. Or it was a conscious thing. I don't know if the owner actually knew this and was giving these cues, but these unconscious cues or conscious cues can affect how a participant acts in a study. And in this case, how the horse acted in these addition problems. So anything that we do as experimenters that biases the results could affect the internal validity. So when we try to control experimenter bias, one of the things we might do, so with the Clever Hans, we might give everybody the same exact instructions and practice reading them so they sound exactly the same. So when we give a cognitive assessment type tool like the Wechsler test, we read the instructions and we try to read it without too much inflection. We try to read it exactly the same to every person we read it to. We could just go and automate procedures and have everything being done by a computer and have the instructions given by the computer. And then we're not going to have any experimenter bias at all. We can blind the experimenter. And what I mean by blinding is just that the experimenter doesn't know what the research hypothesis is. So that in the situation where, we're giving the person the experiment, the research assistant or the person giving the experiment doesn't know what the experiment is about. So they're just reading it. They don't have any idea what the research is about. So they have no reason to have a experimenter bias because they don't know what it's about. Probably the most common example of this is giving a physician giving a medicine to a person, and they don't know if they're giving the actual medicine or the placebo. And the same thing can be done for participant effects. We can blind the participants so they don't know what the study is about. So with that medicine example, they're taking a pill that looks exactly the same as the medicine, but it's a placebo. and so they don't know if they're taking the medicine or the placebo. So there's not going to be any participant effects with that type of study, or they're trying to limit the participant effects. Deception could be used. Deception is telling them the study is about one thing, but it's actually about something else. An example of this would be a study where we're looking at aggression, and we want to see how aggressive people are to others. And we could tell the person the study is about taste preferences, and we have them add hot sauce to something that they're going to give to another person. So with that deception, they think they're giving somebody else hot sauce for their taste, but we're looking at their aggressive actions. Maybe not the best example, but that's deception. Now, deception is something we don't want to use that often. It can cause psychological harm. We think of the famous study Milgram study, where people were giving electric shocks to others, and they were told it was about compliance, or they were told that it was about teaching the other person, and it was actually about compliance. Well, that deception could cause psychological harm. So we don't want to do deception that causes psychological harm. We have to be very careful when we do any sort of deception. All right, so this is there's 10 things here, in 10 confounds to internal validity. So if I had to give you some cues for the quiz, if you knew 4 of them exactly and just kind of knew the overview of the rest of them, you'd probably be okay. I don't play poker very well, and I kind of tell you what's needed for the quiz, but just kind of knowing those confounds, they're pretty relatively simple terminology, but know 4 of them really well.